Assalamualaikum and good morning. We are from Group 4 for subject Fluids Mechanic Lab with code BMM 3521. Our instructor's name is Muhammad Fadzil Faisae bin Abdul Rashid. So today we are going to present about the Bernoulli's principle experiment. Without wasting time, I want to show our group members information with their contribution first. Okay, we are consist of 5 members in this group. As you can see, we divide the task to each member with consist chapter 1 until chapter 5. Okay, I will start for the abstract. Bernoulli principle is the subject of this experiment. The goal of this experiment is to investigate the variation of total pressure head, static head, and dynamic head. The device is made up of several components, including a vectorimeter, a pair of manometer tube, a pump, and a water tank with a pump water controller, a water hose, and pickup tube. The vectorimeter is used in this experiment to measure the fluid flow via a pipe. The converging and diverging portions of the vectorimeter tube function to increase and decrease fluid velocity and lower and higher static pressure respectively. After the level pressure of each manometer 1, 2, 3, 4, 5 and 6 is equal and steady.
Assalamualaikum, my name is Ajwad, MA19149. I will present the introduction for this experiment. Let's start with the background. Bernoulli's principle was formulated by Daniel Bernoulli, where it states that when the speed of a moving fluid increases, the pressure within the fluid decreases. There are many applications in the real world that use Bernoulli's principle. For example, the aerodynamics of an airplane. So even though the Bernoulli principle equation is simple, but it plays a vital role in the technological advancement designed to improve the quality of a human life. So, the problem statement for this experiment that we are required to investigate the variation of total pressure head, static head, and dynamic head. The measurement of total pressure by the pickup tube measurement on the right side of the apparatus. So, static head is measured through the multi-tube manometer. Conventional apparatus is used to vary the static head and dynamic head. So the objective of this experiment is that we need to measure the flow rate through the volumetric tank, and we also need to measure the head, static head currently, and total head at all 6 points within the venturi. And we need to investigate the validity of the Bernoulli equation when it is applied to a steady flow. As for the scope, in this experiment, we will use venturi tube to differentiate the static head and dynamic head. By using multi-tube manometer and pickup tube, we can take the reading for static head and total pressure measurement, respectively. The result of this experiment will be illustrated by graph.
Hello everyone, I'm Kaovinath, son of Appalasamy. My metric number is MA19055 and I'm going to present the theory related to the experiment Bernoulli's principle. So first of all, Bernoulli's theorem states that in an ideal incompressible fluid, when the flow is steady and continuous, the sum of the pressure, velocity and elevation heads along a streamline is constant during steady flow, when the compressibility and frictional effects are negligible. So these parameters can be expressed into an equation which is the Bernoulli's equation. So this is the Bernoulli's equation and these are the representation of the terms in the Bernoulli's equation. So when we multiply the Bernoulli's equation by the specific weight, it gives us a simplified version of the Bernoulli's equation. The P is the static pressure which represents the pressure of the fluid. The rho V square over 2 is the dynamic pressure which represents the pressure rise when the fluid is in motion, is brought to a stop isentrophically. The rho G Z is the hydrostatic pressure, which is not a real pressure since its value depends on the reference level selected. So the total pressure is the sum of the static, dynamic and hydrostatic pressures. Therefore, the Bernoulli's equation states that the total pressure is along a streamline is constant. There are certain limitations which has been imposed on using the Bernoulli's equation. So the limitations are, first of all, the flow has to be steady. The second, the flow has to be frictionless flow. Third, there shouldn't be any shaft work applicable in the flow. As shaft work, like it involves a pump, turbine, fan, or any other machines or impellers, since these devices could destroy the streamlines. Fourth, the flow has to be incompressible, which is the Mach number should be less than 0.3. Fifth, there shouldn't be any heat transfer. And finally, the flow should be along a streamline. And that's all from me. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Cik Siti Nuraishah binti Cik Sapiai. My ID number is MA19093. Today I want to present about the method, apparatus and procedure of the experiment, Bernoulli principle. Okay, the method of this experiment is, in this experiment, the velocity of Bernoulli equation will be required the use of the Venturi system with manometers to measure the pressure head and total head at no point along the flow. The apparatus we use in this experiment is pitot tube, measuring tongue, pipe valve, manometer valve, motor pump, multi-tube manometer, and Venturi tube. The procedure of this experiment is first, the vent valve will turn open, the pump is turned on, and the volume rate was adjusted until 5 liter by using the control valve. The next step is the styling valve was plunked into the hole before start the experiment. After that, the flow rate will measure by using the volumetric tongue. The total of pressure also measured by using the pitot tube measurement with located on the right side of the apparatus. Lastly, the static head was measured through the multi-tube manometer. The flow rate, total pressure, and the static head were measured at all 6 points within the Venturi.
Assalamualaikum and a very good day to the lecturer, Dr. Azimah. My name is Muhammad Akram bin Jamal Akbar and my ID number is MA19099. So today I will present to you about the chapter 4, which is result and discussion. The first one here, we go to the formula. So we have a few formula that I use to calculate the data. The first formula here is about the velocity, which is velocity equal to the flow rate of a cross-sectional area of duct. The second one here we have flow rate equal to the volume over times. The third one here is dynamic head equal to the head pitot minus with head static. Next here we have measured velocity equal to the square root 2 multiply with gravity multiply with head dynamic over 1000. The next one here we have calculated velocity, which is equal to the flow rate over area, and the last one here we have dynamic pressure, which is equal to the rho multiply with gravity and multiply with the heat dynamic. Next we go to the data and result. So we have 5 liters of volume and the time taken is 22 seconds. Here we have the table of calculations. Doctor, you can see on the report on how I use Excel to calculate all these values. Next we go to the graph. As you can see here we have head versus Venturi meters point graph. So first we go to the static head. Based on the static head pattern, the first 3 points here is decreasing, then it went up until the end. As proven by the theory, which pressure decrease as the cross-sectional area decrease, the first 3 points have the smallest and the decreasing in cross-sectional area. That's why it gives this strength. Second, we go to the dynamic head. Based on the dynamic head pattern, unlike the static head, dynamic head trend is opposed to it, as in theory the velocity of moving fluid is vice versa to the pipe cross-sectional area. And the last one, we go to the total head. Total head is the sum of the static head and the dynamic head in the system. The overlapping in the pattern of the first and the second set of the data may happen because of the small difference in allocated flow rate. So next we have velocity and Venturi meters graph. As you can see here, we have measured velocity and calculated velocity. Measured velocity is the actual velocity of moving fluid, which is on the head, while the calculated velocity is the theoretical velocity, which based on the cross-sectional area of pipe and the flow rate. There is head loss in the pipe due to the fluid viscosity near the surface of pipe, which causing deflection. That's why we didn't have the same result here. So for the last graph we have here is the dynamic pressure versus Venturi meters point. The dynamic pressure increase with the velocity of moving fluid. Based on the pattern from point 1 to 3, the cross-sectional area is decreased, which will increase the velocity of the moving fluid, then increase the dynamic pressure as well. So for the last one, we have here for the discussion. From the graph, we can see that the static head is inversely proportional with the inner diameter. The second one, we have the dynamic head will decrease if the inner diameter increase. The third one, we have the measured velocity is inversely proportional with the inner diameter of the Venturi meter. And the last one here, we have the dynamic pressure is inversely proportional with the inner diameter of the Venturi diameter. Okay, that's all for me. Thank you.
So I will continue for the last chapter, which is a conclusion. The result revealed that when the pressure differential increase, the readings of each manometer tube increase. We can deduct from the result that the Bernoulli equation is valid for both convergent and divergent flows because both obey the equation. For both flows, as the pressure difference grow, the time it takes to collect 5 liters of water grows, and the water flow rates grow as well. For both convergent and divergent flow, the total head pressure increase as the velocity of the same channel increase. That's all from me. Thank you.